Hey guys, so in today's video we're going to be going over some more flashcards with Anki. I'm only going to do a handful and I'm going to go ahead and switch over to our collab, and I'm actually going to try just kind of mess around a little bit in collab, and we're only going to be working with our Titanic dataset. And then what I'm going to go ahead and do is I'll go ahead and actually create a classification model, and I'll be using random forest. Now for those that do not know what classification is, in essence you take your data and you attempt to predict something based on the data. Meaning you can predict whether the value is true or false, whether the image is a picture of a cat, dog, or sheep, or so on. It is, in essence, it is guessing what the label would be based on the data that it's been provided. So that is what a classification model is, and it'll just be really simple. I'm not going to go into building a pipeline, nor will I care about well, yeah, information leakage or anything like that. So I'll go ahead and just dive into this. So with regards to our Titanic dataset, something we worked on yesterday is a correlation matrix. Just know that correlation, the higher the value is to 1, the more likely the two columns are correlated. So the reason I'm saying that is because this is what the question is asking. So what will the following do? Titanic.corr. That'll go ahead and create a correlation matrix for us. Now if we do Titanic.survived.corr, and then we're going to go ahead and input the P class, it'll give us the correlation between survived and our P class. So as we see, this is what a correlation matrix will look like. We can always go ahead and turn that into a visual as well, a heat map. And in essence, if it is 1, then that means that the two columns are directly correlated, meaning they are the same thing. And then the higher to 1 that they are means the more likely that they are correlated. And in essence, you should focus on that specific column. So for example, P class with survived is a negative value, so we might consider possibly getting rid of it. Whereas age with survived, that one's a little higher, so maybe we should keep it. And likewise, so will the siblings, or even the parent justification be a justification for why someone survived the Titanic. And then even fair, how much someone paid. And then here's just the correlation. So as we see it right here is negative 0.33. Likewise, we see it right here again, negative 0.33. Survived P class, survived P class. So that feels pretty good. Let's go ahead and move on to this next one. Now, with regards to our Titanic dataset, what will the following output? So if we were to go ahead and run titanic.fair.comSum, what would that give us? So that would go ahead and give us ultimately the sum of the values, and it'll be a cumulative. That's why, yeah. So we'll start at 7.25, and then we'll go ahead and add 7.25 to 71.28, and then from there, that value will then be added onto 7.92, and then that value will be added onto 53.1, and so on, all the way down. So as we see, we start at 7.2, that becomes 78. 78 plus 7.9, that'll go ahead and become 86. 86 plus 53 will then be 139, just about. So that's in essence how we get that. It's the cumulative sum of all the values. Now this one I screwed up on last time. I ran this flashcard for myself. So don't forget, these flashcards are for myself just as much as they would be for like someone that's new. My ultimate goal is to make sure that I remember these so I don't need to recall them or need to go and search for something, some sort of function when I'm really frustrated and I'm not sure what to do with the data set. So with regards to this, what do you think the following output would be? What would be the results of Titanic.not.na.sum? And unfortunately, I'm actually blanking again. Last time I guessed that it was the sum for all numeric columns, but I believe I was wrong on that part. So I'm actually a little frustrated because I want to get this. So if it's Titanic dot not NA and then dot sum. So no, I'm blanking on it. So let's see what the value is. So it will sum. So what's happening here is it'll do the same thing as acquire the length of the column itself, but it will avoid adding in nan or null values, aka it will not add a row if there is a missing value in that row. So as we see with age, although dex should be there too, but we don't have dex showing up because there's a bunch of nan values. So this would be 0, this would be 1, 0, 1, 0, 0. And then we take the sum of all the ones. And so far, based on this picture, we would have 2 ones. Whereas in this picture, for just embarked, we would have 1, 2, 3, 6. So we'd have 6 showing for embarked, and then 2 for deck. Whereas with age, we would have 5 showing, and then that's because this nan is here. So it adds the rows. Somehow we would need to be able to, I'm trying to think of like an acronym that I could possibly come up with for not NA, although you could just do, well, I mean, that could be useful. I don't know. I was thinking of using just length Titanic, then also length dot unique, but I mean, that wouldn't really give us it, would it? So not NA, that could be quite useful. Or even we could do is NA and then add the length, maybe, or like subtract it from the length. I don't know. I'll try to think of something like an acronym, not NA, NN, neural network. No. So not NA, not NA.sum, not NA.sum. Okay. Next up, with regards to this, how would you be able to locate this information, which is just AST? It could be any string you can think of. How can you locate any string within a specific column? Now, in our case, we're going to go ahead and use this as our column. So, what do you guys think it would be? If you don't recall from a previous video, what the result would be is we would have our data frame, which is invoices, column, which is type of meal, so it'd be invoices, type of meal, dot str, dot ends with, and within ends with we'd have AST. I'll just go ahead and show the answer. So this is what I was referencing. So if we wanted to be able to identify if a string value was held in our column, what we do is we do dot string str dot ends with, or dot starts with, or dot contains. I'll go ahead and do one more and then we'll go ahead and jump into Colab. So with regards to this gives us our answer for the cumulative sum. So it returns the cumulative sum. So let's go ahead and just see the question. So we'll just go ahead and click easy. One thing I did notice is that it contained axis equals 0, which is all the rows. But because we're also using .fair, we're just technically selecting just this column. So I feel pretty good with that, so let's go ahead and move on to the next one. And finally, what does the following output? If we have the below, what is the output of age.iloc2? So if we use just this example, what would be the output for age.iloc? So the result would be iloc, which gives us the index location, and index location means 2.9, or sorry, 29, and that would be the result. But if I'm not mistaken, okay, so I actually went over this in another video where I went over the same one and I showed the Titanic data set, and the index location was actually like 48, so it was a little off, but just know whenever you use column.iloc, it's the index location. So I feel really good with that. I'll go ahead and just do easy because I've done that quite a bit. And then we're back to our correlation matrix. So that's a perfect segue to go ahead and move on over to, well, working with our Pandas dataset, or yeah, Titanic dataset. So let's go ahead and maybe import matplotlib. I'm not sure how long this video will be, but I'll try to make it quick. Import matplotlib.pyplot, splt, and then from there, let's go ahead and do from sklearn.ensemble import RandomForestClassifier from sklearn. Let's go ahead. I'm thinking if I should do pandas.dummies to just dummy the data and then give us whatever we need, or just drop all non-numeric values and not even really worry about it. Let's just go ahead and just import whatever else I can. So we've got our classifier. Let's go ahead and do preprocessing. From sklearn.preprocessing import one hot encoder if we need it. From sklearn dot, how about model selection, import train test split. So I don't want to do too much. I honestly don't even really want to do one hot encoding. So I won't do column transformer, pipeline. I won't do any of the metrics. I just want to split it and then just do model.train, model.fit. And then we'll have our X and our Y. So is there anything else? I don't really want to do too much. So let's just, if I need to import one hot encoding, I'll go ahead and do that later as I work through it. But let's just run it. Cool. So now let's go ahead and look at our data, our columns, D types, or like let's do info. Info. And then we have how many null values. So body, like the body weight of someone. Let's go ahead and drop a couple of these. So let's go ahead and just drop our data and then just like create the model itself. So let's go ahead and do dataframe.drop. And then from there, let's go ahead and drop, let's drop body. Go ahead and drop, how about boat? Now let's go ahead and also drop, we're pretty much just dropping all the extra ones for now. Destination, and then let's go ahead and, so what else do we have? Let's also drop our name, since those should all be pretty much unique values. Passenger ID, again, because those should be unique values, passenger ID. And then let's go ahead and also drop anything else. So we have our P class, we'll go ahead and keep sex, age, ticket. Let's also go ahead and drop our cabin, and let's also go ahead and drop our embarked. And then let's go ahead and see what columns we're left with. And then we'll drop axis equals 1, and then is in place equals true. Cool. Now let's go ahead and look at our information again. Let's just see what columns we have left. So we have P class, sex, age, sibling, parch, ticket, fare, and survived. And then we have, let's actually also drop our ticket, and then we'll go ahead and keep our sex as it is, and then we'll just go ahead and use pandas.dummies. So yeah, so I'll just explain what pandas.dummies is in a little bit. So let's go ahead and drop ticket, and then axis equals 1, and then in place equals true. So the reason that I'm doing this is because, like I said, I just want to create a quick one, but I really want to get to pandas.dummies because that is something that I haven't created a flashcard with, but I'd like to go over. So I'll just finish up right now by filling any null or nan values with, how about the mean? Yeah, let's just do mean. So in order to fill the, in order to fill a column in pandas, what you could do is you go ahead and do .fillna, and then from there you can go ahead and pick your rows. Like this collab is actually really awesome because obviously it populates, but sometimes you don't want it to. But regardless, so if we use fillna, we'll go ahead and select our value, and our value in our case will be age. Sorry, dataframe.age, if I'm not mistaken. And then from there we'll go ahead and do the method, which should equal, what would that be? Method would equal, come on. What would we want method to equal? Column list, returns, downcast, limit. Okay, so let's go ahead and just do dataframe.age. So fillna, and then I guess we'll just do the value itself. And then from there, we'll go ahead and just do inplace equals true. So it has been some time since I've used this last. Let's go ahead and see what the result is. That's funny. I'm laughing because it worked. So let's go ahead and see what our, if we have any null or nan values. Great. Now let's go ahead and see info again, so we can go ahead and see which ones are our objects. So the only one that we're going to need to do is now finally dummies. So with regards to pandas.dummies, let's go ahead and just see if we can run it rather than actually working on it. So if we did dataframe.dummies, or pd.dummies if I'm not mistaken. Shoot. Data frame, I don't remember. Let's just run it, see what happens. So no attribute dummies. So what would it be? So if we went to pandas dummies, what would the output be? So it'd be .get dummies. What a great dog. So pandas.get dummies data. So it is just .get dummies. .get dummies. So although this kind of screwed up a bit, what we're going to go ahead and do is we'll just keep finish up with writing the code. So the dog actually just threw my mindset off. What are we doing? So we're doing dummies because I want to do pretty much one-hot encoding. And I believe we'd go ahead and do, what would it be? It would be dummy NA equals true, I believe. Let's go ahead and see what dummy NA looks like. So as a column to indicate nans if false or nans are ignored. If false, nans are ignored. Ah, okay. Let's just see if this works. Perfect. Now, as we see, so the reason I was so happy with pandas.dummies is because, first off, just backing up, I've only really used it once. I'm used to using column transformer and one-hot encoder, and even then, my memory's shot on how to use those. Hopefully in time, I'll go ahead and create more flashcards with it, or just pretty much just work through Kaggle datasets painfully and then just record myself doing it. But regardless, so the reason that we have pandas.dummies or .get dummies, pd.get dummies, is because as we see right here, we have our sex column. It's been divided into the different categories that exist, meaning these categories or these values are the only two values that show in this column. So right here it's going to go ahead and select 1 if it's female or 0 if it's male. And the best part about dummies is it pretty much turns your data frame. So if we're going to go ahead and look at our data frame again, just to double check, we would see that right here, in essence, we have female and male, but we would see that these would be changed from a object or a string to a numeric value. So let's go ahead and save this again. So data frame equals pd.getDummies, and then from there it'd be data frame, and then we'll go ahead and do data frame.head again, and from there it should save it. So now we should have all numeric values. So let's go ahead and check the data types. So we have integers, float, int, and so on. And now we're going to go ahead and work with not NumPy, but we're going to go ahead and just split our data and then just create a real quick data frame. Yeah, so we'll go ahead and just split our data right now. So if we import NumPy, we'll go ahead and do NumPy what is it? Random seed? Is that it? I'm forgetting. We're going to go 42, and then from there we'll go ahead and split our x and a y. So x will equal, what would it be? It'd be dataframe.drop survived. Axis equals 1. And from there we'd go ahead and turn our y into dataframe.survived. And then if we were going to go ahead and do the length of x and also the length of y, we'd go ahead and see what the outputs would be. So it's not random.seed. What is it? Why am I blanking? Oh, the joys of not using Python in quite a while. So what would it be? So we'll go ahead and import pandas. Import numpy as np. And then from there would be what? NumPy.random.seed? No. Random seed. Let's go ahead and see what it is. Yeah, so numpy.random. Oh, did I do underscore? I must have. Yeah. So numpy.random.seed. So we're going to go and seed our values, and all that this does is it makes sure that our data set stays in the same format. So that way if anyone comes back and reruns our code, we don't have a new value populating every time. The data stays the same consistently through, and then our model will give us the same results every time. So we're going to go ahead and run it. Survived. And then they both have the same length right here. So now that we have our x and our y, what we're going to go ahead and do is we'll go ahead and turn the data again just into training and testing. So x train, x test, y train, y test equals train test split. From there it'll be x, y test size equals 0.2. And then if you wanted to, rather than doing numpy.random.seed up here, you could go ahead and do random state, if I'm not mistaken. What would the other option be? So we have type, yeah, so it would be random underscore state equals 42 if you want. And that'll give us the same kind of functionality in the code as numpy.random.seed. So let's go ahead and get rid of that. We have our x, our y, and our test size. Well, let's go ahead and run it. X train. And then, sorry, I'll go ahead and write this out as well. And then we have our x test. So the reason that I'm running this is because I just wanted to show you that when we split our x and our y, when we split the data into training and testing, what it does is it takes 80% or whatever the test size would be. So for example, the test size we chose is 20%, 0.2, and then our length meaning the amount of rows that is selected out of 850, we're taking 20% of 850, and that'll be our X test. And then our X training will be 80% of the remaining 850 rows of data. So now that we have our X train, X test, Y train, and Y test, what we're going to go ahead and do is just pretty much just run the model. So let's go ahead and instantiate the model. So clf equals RandomForestClassifier. And then from there, we'd go ahead and just do clf.fit, X train, Y train, and then from there we'll go ahead and score it. So clf.score, X test, Y test. So let's run it. And then we see, based on this data, that our model is currently predicting with an 82% accuracy. Now, this isn't cross-validation or checking our F1 recall or precision score, nor are we doing a classification report, nor did we even do our correlation matrix to go ahead and see how correlated our data is. The reason I did this is because I want to get into the habit of pretty much just searching for code online and going through and just kind of building these just because, mostly. I have other projects that I'm currently working on, and I'm not really working a whole lot with data science at the moment. It's mostly data analysis, and I'm also picking up my own projects for web developments as well. So I guess you could say full stack almost, but and no life. But I'll just kind of end this video here just by saying that future videos we're going to be creating, or I'll be creating more data science models, and hopefully just in general just getting better at the coding process. So we've only really written 20-ish lines of code here, but yeah. So I'll go ahead and end this video here. If you'd like, please feel free to book a session with me via Snugg in the link below. I'd be happy to go over anything related to data analysis with you, SQL, anything with regards to MySQL or somewhat PostgreSQL. If you want T-SQL help, I'm probably not going to be the person for you. Just generally speaking, I can help out with any general SQL queries, especially subqueries. But yeah, I'll definitely focus on Pandas and SQL if you need help with it. So I'll end this video here, and I'll go ahead and see you guys in the next video. Thanks.